Good afternoon, everybody. Today's problem involves a pulley supporting some blocks that are initially resting on the floor. And we are going to pull upwards on that pulley with different values of force in parts A through C here. It's a really short and straightforward exercise, but it's designed to trick us if we just mindlessly plug and chug values. So let's tread carefully and get started by drawing some free body diagrams. The blocks will experience their weights pulling straight downwards, as well as the tension from the supporting string in the opposite direction. From the pulley's perspective, the tensions will point downwards instead, and of course, we'll have to include our upwards applied force as well. On to the sum of forces. We can save some time and only apply Newton's second law in the y direction because all of these objects only move vertically. One other thing that we can do real quick is focus on the pulley's equation at the bottom and do some algebra to get an expression for the tension in terms of our applied force. Let's get ready to calculate the accelerations of the blocks. I'll start on the left with block A and show the general procedure. We'll take our sum of forces expression for the block and divide out the mass on both sides to isolate the acceleration term. We know how the tension is related to the force, so that part can be inserted next. If we plug in the numbers and grab the result, we can do the exact same steps for the other block as well. But this is the part where the problem is trying to trick us. Take a look at these results. While these accelerations are technically true for objects that can move in the downward direction, that is not the case here. I'll bring our picture back up to show you what I mean. Remember that our problem description said that the blocks are resting on the floor. They're not hanging in the air. That means it's not possible for them to move in the downward direction. Alternatively, you can think of this in the following way. If the weight is larger than the tension that's supporting the object, well, there's no way that the string can pull it up then. Either way, this means that the block's accelerations in part A are actually 0. And those are the answers for this portion. Let's see what happens with part B. All the steps are entirely the same as the last part, so there's nothing new to show here. All I've done is adjust the value of the force to 294 here and here for both blocks. However, it looks like we run into the same problem with block A down here. We can't use this result. Block A cannot accelerate through the floor. So let's go ahead and slap that result away and replace it with 0 like we did before in part A. With that taken care of, part B is good to go. For the final part, we don't run into any negative accelerations at the bottom, so we're good. That's it. This problem was so short, there's not really a need to review everything on the solution card, so I think we can just call it here. Thanks for watching, folks.